Section 3.1 Cartesian Coordinates. Now, in this section, we will see how to plot a point in a Cartesian coordinate system. We will see the distance formula, its applications, and the midpoint formula. Now, first, let's start with ordered pair. An ordered pair, we show it this way. In parentheses, A comma B, is a pair of two elements, A and B. And A is called the X value or X component of the ordered pair, and B is called the Y value or Y component of the ordered pair. Order is important here, the word order, because 1, 3, the order is important. 1, 3, and 3, 1 are different ordered pairs. So the order, tertib, is important. And okay, let's look at this example. Ordered pairs. Use the elements of A, equal to 1, 2, the set 1, 2, as X component. Okay. B equal to 5, 6 as Y component to write 4 different ordered pairs. So we want to write ordered pairs. And this is from A, X component. This is X component. And this is Y component. And we want to use the elements here, the X components from A, and these elements from B. Now, so we will have 4 options then. 4 ordered pairs. So 1, 5. Okay, we take 1 from here as X component, 5, and then 1 again from here, and 6 from B. 2, 5, 2 from here, and 5 from here, and 2 from A, and 6 from B. So we have 4 ordered pairs. Now let's do the try and check. Please stop the video and try to do it by yourself. So it's almost the same question. Use the elements of the set A as X components and the elements of B as Y components to write 4 different ordered pairs. So X component, it can be 1. Y component can be -1. X component, again, it can be 1. And Y component this time from B, it's 2. And again, 2, I can take 2 from here, from A, and B -1, and 2, 2. Yeah, from here it's 2, and from here it's 2. Okay, now let's learn what a Cartesian coordinate system is. A Cartesian coordinate system or rectangular coordinate system is formed by a real line, a horizontal real line. This is the real line we have, real line, and there's 0 here. Now we draw another real line vertically. So it's a real line again, and it has 0 here, and it goes like -1, -2. It goes like the negative numbers are below, -3, and the opposite, the positive numbers are 1, 2, 3. It goes this way. So these are both real lines, and the numbers are here like 1, 2, 3, and it's -1. But the intersection of both real line, they intersect at 0. So the 0 of this real line is here, and the 0 of this real line is here. So this is called the origin. So we will call it the origin. Now, this horizontal real line, we will call it the x-axis, and the vertical real line is called the y-axis. And by using this Cartesian coordinate system, we can locate any point by I mean, we can specify any point with two numbers here. So for example, let's say this is 5 and this is 3 here. So we can say this point is 5, 3. And the first one always comes for the x component. So the number on the x-axis and the number on the y-axis corresponding to the y-axis. And so we will call them as like x component, and this y component of the point. So we will call this coordinate of the point. And sometimes we give a name to point. We can say the point A, the point B, and you can give a name to the point. And now here there's a nice picture of it. Now you can see everything clearly because there will be the grid. There will be a mesh grid, showing all the numbers and the corresponding points. Now this is better here. This is origin, and I said every point will have two components, like x component and y component. Look at so the origin has this component here, like 0, 0, because it's x component 0, y component 0. And when you take this point, this is like 7, 0. So 7 on the x-axis and the y-axis is 0. And this point, these points, I mean this part here is called quadrant 1. This part of the Cartesian coordinate system is called quadrant 2. And here it goes the third quadrant. And here is the fourth quadrant. And as you see, when numbering them, we go this way. So this way is like, we call it counterclockwise. Counterclockwise. Wise direction. So this, as you know, the clocks are going like this, 1, 2, 3. So they go this way. So this is called clockwise direction. So in mathematics, when dealing with the Cartesian coordinates and the angles, you will see in trigonometry, and in this Cartesian coordinate system, 1, 2, 3, it's always counterclockwise direction. So we go always counterclockwise direction. So we have 0, 0 here, and any point on the Cartesian system as a coordinate. And how to find a coordinate? Okay, you have to be able to, when we locate a point, you should be able to tell its x component and y component. It's easy. Like here, 7 for the x component and -7 for the y component. And also you should be, we should be able to locate the point when the coordinate is given. For example, you want to find, let's say 5 to -3. So here, what you do here is you go x, on the x-axis, you go to x, to find 5 on the x-axis, then you make this vertical line, and you find the y, -3 on the y-axis. You make this horizontal line, and then you locate their intersection, which is 5 -3. Okay, I think in the next slide you will see plotting points. We will learn it better. There is one more thing about the Cartesian coordinates, especially about the quadrants. In the first quadrant, it's here. the old components here, the x and y components, are positive. So here, when you look at here, we have negative numbers and positive numbers here. So all the ordered pairs or all the points have negative x component and positive y component. And in the third quadrant, it's negative and negative, because we have negative numbers you see on the x-axis and the y-axis, and on the x-axis it's positive numbers here and the negative numbers here. So in the quadrant 4 there will be positive x components and y components will be negative. So that's one important thing. We will use it a lot in the trigonometry. In the second term, math 112, you will use this a lot. Plotting points, put the following points on rectangular coordinate system. Okay, 4, 0. 4 is the x component, and y is equal to 0. Y equal to 0. You find x equal to 4 on the x-axis and y equal to 0 on the y-axis. Then you make the horizontal line. You make the horizontal line from the y-axis, and you make the vertical line from the x-axis, and their intersection is our point here. This is the vertical line. This is the vertical line from the x-axis at 4, and this is 0, and you take the horizontal from here, and it gives you 4, 0. 4, 0 is here. And negative 2, 4, you find negative 2, make the vertical line, and negative 4 from the y-axis, so you make this horizontal line, and then their intersection minus 2, 0. And again, let's look at D. Well, find y equal to 0. Find y equal to 0. Y equal to 0 is here. So from the y-axis, you make x equal to 0. Sorry, this is x equal to 0. Y is equal to minus 4. X equal to 0. From the x-axis, you take a vertical line, and y equal to minus 4. Y equal to minus 4 is where? It's minus 4 is here. You take a horizontal line, so this is the point. D is this point. Now again, if you want to find a point, you take x equal to a, and you make a vertical line, and from y-axis you find b, and you make the horizontal line, and this becomes point AB. The intersection becomes AB. Now let's try to do it again here. Pull out the following points on the rectangular coordinate system. Plot means here show. Okay, like draw it. We will locate and show the points here. 3 minus 2. Okay, 3x in the x-axis is equal to 3. Y-axis minus 2, 3. So we take the vertical line, and minus 2 is on the y-axis here, so you take the horizontal line, so it becomes the point 3. Okay, 3, negative 2. Now negative 4 is 0, so x on the x-axis, find x equal to minus 4. It's here, and then make the vertical line, and y equal to 0. Y equal to 0 is here, and you take, so this is y-axis all the time, this is x-axis, and then you take this horizontal line, so it's called, here we will have the intersection, it's minus 4, 0, it's B. Now, two, 4. 2, 4 is 2. Take x equal to 2, it's here. So you take the vertical line, It's 4 on the y-axis. It's here. Take this one, and its intersection is here. So c equal to 2, 4. Zero, 4. Let's try to do it. 0, x equal to 0. It's here. So we are taking the vertical line. Okay, it will be bad. So I raise these. Okay, then 0, x equal to 0. I take the vertical line, y equal to 4. Y is here. Take this one. And now this, their intersection gives you the 0, 4. Distance between points. Now we will learn how to calculate the distance between points. If you have 2 points on the Cartesian coordinate system, then you can calculate the distance between them. Here is the formula: x2 minus x1 squared plus y2 minus y1 squared, and take the square root of this. The idea comes from, okay, here I want to talk about the idea here. The idea comes from here. For example, you have, assume it's here, x1, x2 is here. I mean, x1, y1 is here. And y2, y1 is somewhere here. x1, y1, x2, y2. So the idea is, okay, what's the distance between them? Now, you can use the right triangle, the Pythagorean theorem here. So this, if you say this one is, what is this equal to? This is y2 minus y1. And you can take the x2 minus x1. How can you find the distance here? The distance can be found by using the square, the sum of the square of this and square of this. So d squared is equal to this y2 minus y1 squared plus x2 minus x1 squared. And then you take the square root of both sides, and you get d. D is positive. So this idea is coming the right triangle, Pythagorean theorem for the right triangles. Now let's use this formula in this question. Find the distance between P1 comma minus 2 and Q5 comma 3. And you can see here this is x1, this is y1, and x2, y2. And then you can put them in the formula here way. And then when you put them in the formula, you can use you will have a 5 x2 x1 y2 y1. By the way, you can switch them because we're taking the square. So the square, when you take it like x1 minus x2 squared, it won't affect the result because we have square here. So this is the negative of this one, but when we square them, they're same. So they will be equal. So after calculating this, so we have to be careful about this minus issues, and then we have square root 41. Now, if you want to visualize it, you can plot the points here. 1, minus 2 is P, and this Q, 5, 3 is here. Q is this point. And again, the idea here is using the Pythagorean theorem here. So the distance here and the distance here is calculated, and you take the squares and get the sum and get the hypotenuse of the right triangle. So let's look at this try and check exercise. Which of the points P and Q is closer to the point R. So if you want to learn which one is closer to R, we have to compare the distances between PR and QR. So we will compare distances PR and QR. Now, what is PR? PR is square root. Okay, you take 1, subtract minus 2 from 1. Take the square, and then you take -3 and minus 1, subtract. And what is this? Square root of 3 squared plus minus 2 squared, which gives you square root 13. Now, QR is square root -3 minus 2 squared plus 4 minus 1 squared, which gives us square root. This becomes minus 1 squared, and this becomes 5 squared, becomes square root 26. As you see, PR, the distance from P to R, is less than the distance between QR. So if you write with the notation here, the Cartesian coordinate notation, the distance between QR and the distance between PR is less than, yeah, the distance between PR is 13, square root 13, and this is square root 26, and this is obviously bigger. So we say P is closer to R. Now, let's see the Pythagorean theorem, the converse of the Pythagorean theorem. The converse of the Pythagorean theorem says if the sides ABC of a triangle satisfy this equality, then the triangle is a right triangle with legs having lengths A, B, and the hypotenuse having length C. So first, let me remind you what is Pythagorean theorem and what is its converse. First, Pythagorean theorem is this. Pythagorean theorem says in a right triangle, so in a right triangle means like this is 90 degrees and we have here A, B, C, and this is the hypotenuse C. And if this is the case, if we have 90 degrees and if we have a right triangle, then the relation between the sides are this: A squared plus B squared equal to C squared. So the sum of the squares of the side lengths is equal to the square of the length of the hypotenuse. This is Pythagorean theorem. And the converse Pythagorean theorem is saying this. You have a triangle, but you don't know it is right triangle or not. So right triangle means here you don't know if there's 90 degrees in it or not. Okay, if you don't know if it is right triangle, so it means you don't know 90 degrees is there or not. You don't know, but you know that A squared plus B squared is equal to C squared. Then if you have this condition satisfied, then you can directly say, yes, this is a right triangle. So if someone doesn't tell you if it is right triangle or not, you can directly check this one. If someone gives you a triangle and say, is it a right triangle? You can directly check this equality and say, yes, there is 90 degrees in it. So it's a right triangle. So right triangle means this one here. Right triangle. Anyway, so this is the difference between the Pythagorean and the converse Pythagorean. One is we already know right triangle, and we have this equality. And in the second one, we don't know if it's a right triangle. We say if this is equal to, if the equality satisfies the Pythagorean equality, it's definitely a right triangle. So let's use the distance formula in this question. So determine whether or not the points A, B, C are the vertices of a right triangle. So the vertices of a right triangle, so it's asking this, like, is it something like this, for example? Or it might be, of course, we don't know which one is 90 degrees. It might be like this, you know, B, A, C, we don't know. But the question is, is there a 90 degree on it? I mean, in it? So do they form a right triangle? This is the idea. The vertex means come from the vertex. These are the vertexes. There's one vertex, there's another vertex, there's a vertex. So the plural form of vertex is vertices. Vertices. So of course the idea is we have to check if we have a squared plus b squared equal to c squared. Do we have such thing? So here a is in a, b, so we will check the distances between a, b, a and b, b and c, and a and c. So this is how we do it. Now we can put them in the Cartesian coordinate system and use the distance formula for each, like from A. So where is this A? Okay, this is B, this is A. You don't have to draw this, you don't have to plot the points. You can directly check the distances, like AB. The distance between A and B is 0 minus 2 squared. Use the distance formula, and you will get square root of 8, which is 2 squared 2. And AC is, the distance between AC is 7. And now the distance between, now we found this part, and then we will find this one, and we find this one, square root 29. And 7 is the biggest one, right? 7 is the biggest one. So we have square root of 8, square root of 49, square root of 29. Which one is bigger? The biggest one is square root of 49. So if it's a right triangle, the hypotenuse, the biggest side should be this one. So we check this one. We check, is this equal to the square of the short sides? Is it equal to 7 squared? So because this is the biggest side. These are the shorter guys, shorter sides, short sides, or short sides. And we check that if we have a squared plus b squared. Let's see. So the longest side is 7. We know it's here. So when you compare these, square root 18, square root 49, square root 29. So square root 49 is the longest side. And then it's the possible hypotenuse. So we check the square of the shorts is it equal to 49? No. So it's checking this, a squared plus b squared equal to c squared. Is it? No, we got 37 here, we got 49 here, and this is not true. So we say so this is not, these points are not the vertices of a right triangle. Okay, one other application of the distance formula is the collinearity. Collinear means on the same line. So if, okay, A, B, C are on the same line, means this, A, B, C, let's say. these are on the same line, or it might be in different order, like C, A, B. Okay, the question is, how do we know if 3 points are on the same line or not, or collinear? In other words, are they collinear? So it says if one of the following equalities is true, then we say they're on the same line, so they're collinear. You can check this, the distance between the sum of the distance of two of them is equal to the other one, then they're on the same line. So we don't check all of them. If one of the following is true, one of them. If one of them is true, so you check them, like it's one of them is true, then they're collinear. So for example, look at here, these points are on the same line. You can check here, this one here, intuitively, it's obvious, like if they're on the same line, the distance between these two and the distance between these two, when you add them, it will give you the distance between B and C. Now let's look at this problem here. Example, are these points collinear? So are they on the same line? So what we have to do is we have to check the distances between them. We check the distance between each pair of points, A, B, A, C, B, C. And then you check, okay, you can simplify them, or you don't have to. In some cases, if you will take the square of it again, so you don't have to. This is like 8 squared, 50 squared, 18. And then, okay, simplification is here. It's important. Okay, we will see now. So because when you add them, so you cannot add these two. In order to add them, you will try to simplify it again. So it's better you use the simplified version. We don't take the square here. Sorry, I made a mistake. So we don't take the square. Then it's obviously 2 squared 2 plus 3 squared 2 is equal to 5 squared 2. So the distance between AB plus the distance between BC is equal to AC. So it turns out on a line, it's something like ABC, or CBA. I mean, for sure B is in the middle, in somewhere between A and C. So we say they're collinear, or in the same line. Okay, let's do this try and check exercise. Are the points A, B, C are collinear? Are they collinear? We will compare we will check the distances. Okay, check the distances. Step 1, I can say, find the distances. Find the distances. Like A, B, B, C, and AC. Okay, let's try. So AB is equal to square root 2 minus 1 squared plus 3 minus 2 squared, which gives you square root 2. And BC here is square root, 3 minus 2 squared plus 8 minus 3 squared. This makes square root 26. And AC is a square root of 3 minus 1 squared, this one and this one here, plus 6 squared, like 8 minus 2 squared. It will be 4 plus 36, so it will be square root 30. So step 2 is, step 2, take the biggest one, and check, this is 40, and then check if this is equal to the sum of the others. Okay, we will check that. Now, how can we check it? We have to compare these two values. How can we check it? Okay, this is one way is to use a calculator. Okay, then you can find this numerically and find this one numerically and say, okay, which one is bigger than the other one. Okay, we will not use a calculator. Okay, without the calculator, how can you see it? Okay, if the numbers are big, I mean, still you have to use a calculator because it will take a long time to calculate. But here the numbers are okay, so we can try that. So we can try to, if we want to check if it is equal to or not, we can check their squares. So check their squares, 40. Now this makes like 2 times square root 2 times 26 plus 26, which makes 28, plus 2 times square root 52, and 40 are they equal? Are they equal? So the question is, are they equal? If they are equal, so you can send this one to the other side. You can get like 12. Is it equal to 2 square root 250? 2 square root 52. Now then divide by 2. Still, I mean, we are checking. We get 6 equal to square root 52. Is it true? No. Definitely no. So for this reason, so we say they are not, or these points are not collinear. So these points are not collinear. We found it because we saw this is indeed, this part here is bigger than, this part is bigger than square root 40. So these points are not collinear. So, I mean, we are checking for the equality and there is no equality. Now the midpoint formula. The midpoint of the line segment with endpoints px1, y1, qx2, y2 has the following coordinates. The line segment, the midpoint. Okay, I will show you this. What are they? So these are, okay, this is a line segment, and these are called the endpoints. Okay, this is an endpoint, and this is another endpoint. The midpoint is the point just in the middle, so distance between them is the same. I mean, the middle point, the distance between the middle point and to the endpoints, they're same. So this is, we call it, this is midpoint. So let's say the endpoint is, so basically it's saying if it is x1, y1, and this is x2, y2, and then the midpoint here, its coordinate is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we add the x components, divide by 2, we add y components and divide by 2. Okay, let's see an example. Okay, find the midpoint of the line segment with the endpoints A and B. Now we use the formula here. This is, you can say this is x1, y1, this is x2, y2, and use the formula here. And you put them here in the formula, and you got 1, 4. So 1, 4 is the midpoint between these 2 points. Find the Okay, let's do the try and check exercise. Please stop the video and try to do it by yourself. Find the midpoint of the line segment that connects points A and B. Now this is x1, this is y1, and this is x2, this is y2. And the midpoint formula, as you know, this is x1 plus x2 divided by 2, their average. And y1 plus y2 divided by 2. So the midpoint is 0, 0 over 2, 0. This one here is 8 over 2, 4. So we have the midpoint 0, 4. Okay, let's look at another example. It says, given point Q minus 1, 6, find the coordinates of the point P if the midpoint of the line segment PQ is M negative 3, 2. Q is given, we know that there's Q, point Q, and find the coordinates of P, and there's a P here or somewhere, and the midpoint of the line midpoint of the line segment here is M. So it's saying this is M is negative 3, 2, and Q is minus 1, 6. So here they find the coordinates of the point P. Okay, this is the question here. So you can try to assign an unknown variable here. So you can say this is X and this is Y. We can say A, B, whatever, and then you can see this is A. Okay, the midpoint formula is like A plus minus 1 over 2 is equal to the midpoint, the X coordinate of the midpoint. And if this is B and this is B plus 6, B plus 6 over 2 is equal to the Y coordinate of the midpoint. Then you can find A and B. Now this is the idea. You can use X and Y or A, B, whatever you like for the unknown variables. Let's see how it is done in the slide, how it is written in the slide. So it says, let X, Y be the coordinates of P. So this is the situation now, Q minus 1, 6. And P here is, we don't know, but its coordinates are X and Y. Okay, this is X and Y. And the midpoint is 3, 2. And okay, of course, using this, we get this one. And we get from here, we solve it, and we get X equal to minus 2. So multiply both sides with 2, you know. And then you will get this one. That gives you X equal to minus 5. On the other hand, you can relate these Y components to 2. So Y plus 6 over 2, so you multiply both sides with 2, there will be cancellation, and you get Y equal to minus 2. So the coordinates of the midpoint